Thanks for your introduction, Stuart. Can you afford to grow crops without a biological approach? Right now, most Australian farmers are doing exactly that. We're investing in fertiliser, pesticides, infrastructure, machinery, but we're largely ignoring the billions of microbes beneath our feet. I'd like to thank my sponsors, the Tasmanian Institute of Agriculture, the JM Roberts Charitable Trust. I'd like to thank Nuffield Australia, our 2024 cohort, who are awesome, and the greater Nuffield community for enabling this incredible experience. And of course, the family farm, our business Van Diemen Quality Bulbs, my mum, dad, and my sister Meredith, and my wife, Moira, and the kids, Lucy, Margot, and Angus. They've been incredible supports through all of this. Are we missing a trick by not researching, developing, and trialling biological tools to assist with resilience and production? Around the world, the farmers that are doing it well are more profitable, have fewer risks, and are developing more markets. Today I'll be talking about what is biological priming, why it matters, and methods to achieve it. I've broken these down into, can you grow a soil community? Can you apply it with bulk amendments and targeted amendments? And I'm going to particularly just touch on compost extracts just because they're so interesting. As Stuart said, I'm from northwest Tasmania. Our family grows flower bulbs and other crops. The business is vertically integrated. We're doing direct sales, and we also do tourism, have a tourism operation. And that means we're quite close to our customers. They want top quality, they want it grown regeneratively, and they want it at a decent price. We're not always able to achieve that. And things didn't, and it's hard sometimes, things didn't look like they were getting easier on the farm. I hope this biological approach would solve some problems, enable a legacy that would enhance our business, our farm environment, inspire me, my community, and my children. In my individual travel, I travelled to New Zealand, Chile, the UK, Netherlands, France, USA, and the great states of Queensland and New South Wales. Farming is complicated. This slide shows the factors that contribute to yield and profitability. These are all the factors that microbiology contributes to. Healthy functioning soils are the foundations of farming. I think we can all agree that healthy soil translates into healthy crops, that translates into healthy animals, healthy landscapes, and people. My question is, I started asking questions, how do we quickly recover soil from our mistakes? How do we keep soils functioning and improving while still farming productively? The question I pose is, can we encourage, manipulate, introduce biology to help us grow healthier, more resilient, and more profitable crops? We all have different motivators. Farming is a bit like playing snakes and ladders. You don't control the whole game, but you do get some influence over the dice. Make the wrong moves and you'll hit the snakes, and they'll send you and your business sliding backwards. Make the right moves and you'll climb the ladders and lift your production, resilience, and profitability. The key is knowing which are the big ladders and which are the big snakes in your environment. I believe there are significant ladders that many Australian farmers have not put to work yet. I'd like to show you that biologically priming means you may still have ladders left in the shed. Soil biological priming affects us all. I came across work by Dan Ketteridge and the Bionutrient Institute. They're doing science on understanding how to grow high-quality food. And they're doing beyond the nutrition, the vitamins, minerals, polyphenols, all the other parts, fats and everything. And they're asking the question, what are the practices that contribute to high-quality food? The good news, we don't have to rely just on the science, is that flavour is a good indicator of quality. Yay, that's really great for us. Quality is a good indicator of biological activity. So in this chart, there is an example of antioxidants in wheat. And so there's a spectrum of samples of wheat. And more antioxidants, I think we can understand, is better. So what I'm really interested in is all the guys out on the green. What are all those samples? What are those? What are the practices that led to them getting out there in that light green area? And what's that guy doing right on the right? There must be some practices that they're doing that's different to what the average person's doing. It all starts with a seed. At its simplest, biological priming is all about the first 10 days of a seed's life. Success can be about manipulating and encouraging that environment. Those first few days decide how well a plant establishes, how resilient it will be, and even how much it will yield later. We are always priming, we are always working with biology in farming. It's on everything, in everything. Seeds are no exception. There are endophyte microbes inside seeds and outside seeds. These microbes have a front row seat to colonise new roots. But here's the catch. Are they the right microbes? Are they the right ones turning up on the day you need them? As farmers, are we just rolling the dice? Or can we influence that outcome? Our climate and processes aren't always supporting good endophytes on seeds. Things like seed dressing, chemical seed dressing or treatments, freely available salty ferts, broad-spectrum fungicides, and especially interesting hard, dry finishes can reduce the total number and diversity of these species. Endophytes are like colostrum for the seed. You can either foster them or you can apply them. Either way, the first 10 days matter. One method for biologically priming the soil community is the traditional way. So these are cover crops, crop rotation, all the classics. What's new, I guess, is there's more interest and significance looking at polycropping. So to microbes, living roots are like a party. No living roots and the party's over. But if you really want to get the party to pump, polycultures are where it's at. They really drive exciting new interactions. There's more energy and diversity. No one wants to leave the party until the beer tap of sugars are turned off by the plants. The party can wax and wane, but if we want resilient soils, we need to keep the party alive. Another common method of biological priming is whole farm amendments. There's some good options here, including compost, carbon-based fertilisers like biochar. These amendments can be less feasible for many farmers as transport distances become more cost prohibitive. But used strategically, they can be really significant. Another way to unlock the benefits of compost is through an extraction process. Mixed with water and filtered, these liquids are easy to apply in very small amounts. They can be cost-effective and cheap. I think there's maybe a kind of arrogance in the way that we always think that we can understand exactly what a plant needs, when it needs it. Compost extracts bring a kind of humility back to farming. Instead of trying to micromanage, we supply a huge diversity of microbes, metabolites, and signalling compounds. then let the plant decide which species it wants to recruit. It's a different way of thinking about it. I've seen this work in 3 continents. In England, I visit G's Fresh. They are huge. They have about 60% of the fresh lettuce in the UK and about 70% of the celery. Huge company. They are using these methodologies there. And I think it's particularly interesting because it's leafy greens. They're normally terrified of anything biological. This extract was applied on cover crop seeds and then at planting. Surprisingly, it fitted in with their fungicide-drenched seedlings. They were still getting effects. For G's Fresh, and they had benefits from an ESG standpoint, all the way to disease management, university of their lettuce and celery, with 20% larger heads, darker, glossier leaves, and longer shelf life. While in Brazil, I was lucky enough to meet up with Aurelio Pavato from SLC Group. That's a farming company that's growing on about 16 farms, and I've heard from the Brazilian scholars maybe more. When I was there, it was just a mere 500,000 hectares of soy, cotton and corn, and I heard anecdotally it was maybe up towards 800,000 hectares today. They are taking this seriously. They have built factories to multiply beneficial bacteria and fungi, applying them at planting, post-planting, to stimulate soils and plants, target diseases and insects. Biological amendments are common throughout Brazil to reduce cost and improve outcomes. Small targeted inputs, the right microbes at the right time, work well in this environment. So yes, biologically priming soil is important and effective. A few key points. Success doesn't equal input. It equals compatibility, environment, and timing. Once you learn the methods, you can just start applying these across other crops. Small amounts can make a big difference. Positive changes can appear in cropping in that first year, and you may see changes in the first 10 days. So I leave it with you with a question that I opened it with. Can you afford to grow crops without a biological approach? Thank you, and thanks to my sponsors.